and as we make progress, we see some of those policies. But there are still gaps in the sector, hindering the realization of these potentials. Let me give you an idea of some of the potential. It's estimated that if we're able to put solar panel on just 1% of the land mass of Nigeria, which is over 928, if I'm correct, 1,000 square kilometers, that we should be able to generate enough power. And this is a Energy Commission of Nigeria's estimates. But why are we still where we are? And I would narrow down to policy standards and regulation. Number one, we don't have a comprehensive energy policy. Secondly, even the ones we have, enforcement is still very weak. Some government policies are also not consistent. For example, Nigeria plans to achieve net zero, what we call net zero. That means we expect a lot of climate mitigation, and adaptation measures that would enable us to achieve net zero by year 2060. But there are still some policies that is pushing emission, right? And then the issue of standards. So, like I said, my presentation will be very specific around policies and regulations. So what are some of those policies in Nigeria? The National Energy Policy, which has been revised now 2022, also part of the team that provided some support in revising this. It provides a framework for integrating renewable energy sources in Nigeria. In fact, Nigeria has a policy and a vision called Vision 30-30-30, which means by 2030, Nigeria should be generating 30,000 megawatts of power, 30% of which will come from renewables. Okay, but emphasis has been on standardization of renewable energy technologies to ensure quality and efficiency. That's the provision of that policy. A very strong policy for Nigeria. I mean, that's anyone who is interested in the space should read. There's also the Renewable Energy Master Plan that was updated 2011. I was also part of the team that worked on this. It's a roadmap for increasing the share of renewable energy in Nigeria. This is where the Vision 30-30-30 comes from, and it calls for adoption of international best practices and standards for solar energy components. Remember, we are hovering around standards and regulation and policies. So this document, the master plan, clearly itemizes the issue of standards as very important in achieving, the potentials that we have in Nigeria. And also there is what we call the NREP, Renewable Energy and Energy Efficiency Policy, that was signed 2015 into policy, and establishes guidelines for solar PV and battery system. It advocates for local production, so there's local content to say, look, can we also be producing some of these components in Nigeria? And that's what led to the death of there's an organization called Naseni. Naseni has a solar assembly, right? Plant somewhere, I think it's Nasarawa State, if I'm correct. And then projects and programs like Nigerian Electrification Project is now become DES, Distributed Renewable Energy Scale Up, is under the Rural Electrification Agency, and the framework also mentions the issue of quality and standard, and that is very critical to Nigeria. So we have some of these provisions in existence that we're wondering why we still have some substandard products in country. We'll see why. In terms of regulatory standards and guidelines, mini-grid became very popular in Nigeria recently. Nigeria has one of the best mini-grids in sub-Saharan Africa. A mini-grid is set up in a location where there is no grid at all. And let me also remind you, almost 45% of Nigeria is not anywhere near the grid. That means there are no, all those high tension wires that you see. So that means they've been in darkness, except how they generate power for themselves. So a policy that was put in place and also now revised by the Nigerian Electricity Regulatory Commission, also one of the stakeholders, encourages setting up of what we call mini grids. So as a project developer, my company will have some mini grids that we're running. You go to a site where there's no grid, you get the permit of NEC. NEC is Nigerian Electricity Regulatory Commission. You set up a mini grid. There's what we call the grid code. There's a minimum standard of cables, poles that you should use. So it's standardized. And it requires developers to use certified products. In fact, there's a program in collaboration with Rural Electrification Agency, and there are standards you have to use in terms of the solar panels, the cables, the batteries. Those are specified. There is an agency called the NEMSA, Nigerian Electricity Management Services Agency, and there's a regulation around this that enforces installation and safety standards. So for mini grids, for example, NEMSA is expected to inspect, ensure that the proper cables are used. So you don't use a 4mm cable where you're supposed to use a 10mm cable. I don't mind me, I'm just an economist, and I'm sure our engineer here will tell us more about these terms I'm saying. So they do inspections and then also certify solar installations. In fact, if you want to really operate in the space in Nigeria, in renewables, you must have what we call NEMSA certification that qualifies you to be able to install these systems. All right. Then there's what we call the Standard Organization of Nigeria, who recently, and I think it's been concluded already, if not already concluded, setting up standards particularly for solar panels in Nigeria. And then they adopt the International Electrotechnical Commission, generally we call it the IEC, for Nigeria. And SON enforces quality control, and they are expected to, in terms of importation and even locally manufactured products. And then there's the Nigerian Customs Service, particularly when importation is being done, working closely with SON to inspect imported items. In fact, there's a document called the SONCAP certificate. And this is a conformity assessment program, I think, SON SONCAP, that you are expected to do before you import this product into Nigeria. So there are standards, there are guidelines in place. Then Nigeria has also been part of the international system adopting international standards. So typical ones are ISO, IEC, the UL, the TÜV of this world. And then particularly there's one called the Verasol for small solar systems. So many of us will have been seeing Pico Solar, Solar Lantern, solar system that comes with fan and 3 light bulb. So they are expected to be Verasol verified. And some of those numbers are what I've quoted here: IEC 61215, IEC 62133, ISO 5001, around energy systems, particularly renewables. So in terms of gaps, so we have policies in place, but there are still gaps. For me, one of the critical constraints I see is actually implementation. That's the one we have not been able to implement fully. So what are some of those gaps? I'd like to look at 3 big things. So I'll pick just 3 of these. One is lack of comprehensive renewable energy policy. So we have several policy frameworks in place. I mentioned the NEP 2011 revised, Renewable Energy Master Plan, the Nigerian Renewable Energy and Energy Efficiency Policy. There are still many others, right? So everyone's standing on its own silos, not even considering existing one in bringing up new policies. Okay, so what should we do? We need to develop a legally binding policy and with measurable target. In fact, we need to have an act. So it's not enough to have Renewable Energy Master Plan or policy framework. We need a Renewable Energy Act. Ghana has. I think Tanzania also has. Kenya. So policies is really not as strong and as effective as an act. An act is I don't meet the standard, there are penalties that could be taken to court. The policy is just setting the roadmap and framework, right? It might not be enforceable in a law court. So we need acts. Then we have weak enforcement of even the existing regulations. I mentioned the Nigerian Electricity Regulatory Commission, the REA, some of those provisions that we've had. For example, there's a minimum standard that should be certified under the SONCAP that I mentioned. Remember, SONCAP is SON Conformity Assessment Program. That even before the panels get into the shores of Nigeria, you expect to do this through inspection agents abroad and ensure that it's only qualified and certified product that comes to Nigeria. But I can guarantee you that more than 60% of the products still coming to Nigeria, I don't meet this standard. So if you're wondering how. But so enforcement is also an issue. And then when it gets into market, there's still no enforcement around, adopting the NAFDAC model. I use the word NAFDAC model, where it has come to the country, but you still go around and check and meet importers to say, look, this does not meet the standard. We are confiscating this. We are destroying it. It's still not happening yet in the energy space, and the NAFTA model needs to happen in the energy space. So we need to strengthen regulatory oversight and stricter penalties. So control, regulation, and penalties for non-conformance and non-compliance. Once this product gets into town, most of these guys get away with it. And so there's no penalty. And then inconsistent government support. So at times, government makes policy to say, look, so we want to reduce emission, we want to encourage the deployment of renewables. And on the other side, they're also bringing policies that is inconsistent with that target. So there needs to be consistency. In terms of standardization, there's lack of enforced technical standards. So we don't have a unified national standard for solar and inverter and batteries. I think SON is working on this. I was also on one of the working groups. I will reconfirm if it's been finalized. So what do we need to do? Just conclude what SON is doing. It's a very comprehensive work, and I believe once it's finalized and adopted by Nigeria, it will help to regulate that sector. So you find out that there are different types of, for example, batteries. Some you can't even get warranty. You use some batteries. Some customers will say, look, I bought a battery and 6 months is dead. So I don't want to use these technologies again. I'm not sure. Okay, but standards, once they are enforced, will ensure that some of these products don't get into Nigeria, and it does not discourage adoption, because it actually discourages adoption. Let me say a typical example, maybe a tubular battery. Conservatively, you buy at 250 or 300,000 one unit. So if you are deploying 4 or 8, you know how much that is, and then you spend that money and then it doesn't work. It's a big disincentive, which Nigeria needs to begin to enforce standards against. Then there's also quality control issues. I've mentioned this. Market is flooded with substandard products. How they get in, I don't know. But they are discouraging adoption. Most people say, look, my experience, we've seen where customers bought solar and then they had to go back to their generators because it didn't work, and it's really very, very painful. Then there's also the issue of grid integration and standard. So in Nigeria, we don't have what we call grid integration with renewables yet. So I live in a house that has been powered by solar and battery backup 100% exclusively for over 10 years. So as I speak right now, maybe my batteries will be at float. Our engineer will explain what this means. They're the ones that taught me some of these jargons. So that means my battery has been fully charged, and then the excess that is being generated, because the panel on my rooftop will continue to, generate electricity energy as long as the sun is up. So I'm unable to sell this excess energy generated to a disco and make money. Many countries have what we call the net metering framework, where I can sell to the grid. But in Nigeria, we haven't gotten that yet. So it's also affected because the grid is challenged. There are fears that if you plug in maybe 1,000 megawatts of solar PV generation, that it might disrupt the grid because the grid is obsolete, is old, and needs to be enhanced. I know that Nigerian government with Siemens is working on expanding the grid to about 25,000 megawatts capacity. But we're looking forward to this. Policy and regulatory strategies. So enforce national and international standards. Get the SON to repeat this again. We need to strengthen importation controls way into town. A typical example, in Ghana today, you cannot bring in incandescent bulbs or substandard solar panels because the importation controls are very strict. And if you just find a way of doing that, a solar installer, and then you just go and install solar, is a big issue. Both the installer and the client who permitted someone to climb a roof without a certificate will probably go to jail. Probably. So this strengthens standards in those countries. We need to adopt that. I mean, it's like saying, I'm going to the hospital, I want to see a doctor who is to perform surgery on me, and he is not certified. I mean, you and I won't try it. It's similar. So it's only engineers, qualified, certified, that should do the technical jobs. And then the issue of quality assurance and certification programs. I've mentioned, SN. Drugs, if you go to the pharmacy and buy drugs, I believe almost all the drugs in Nigeria, you are looking out for NAFDAC number, right? We need to have that also in renewables, where you see SON certified, NAFDAC certified, SON certified. In fact, it should be possible for you to scratch and put a code on your phone and certify if this is genuine or not. You can do it with drugs. So really, I mean, a lot of things to do. Then there's also technical and industrial standardization. How do we implement mandatory testing for facilities? So we need to have testing facilities. I know a few. I know about 2 or 3 private sector players. I also know that SON somewhere in Ogba, Ikeja, Lagos, have a solar panel testing facility in place. But we need much. We need more. We need to involve in R&D to improve efficiency of systems that are both manufactured locally and also imported. Training and certification of installers. I mean, as the pioneer president of the Renewable Energy Association of Nigeria, I have been hammering on this, that is only certified, qualified, and trained installers that should install solar systems. No one else should do. Some of us, other people like us who are business people cannot just run businesses. But it should not be permitted for someone like me to say, I want to go and install solar. I'm not an engineer and I don't have current certification. I can only hire an engineer, which I have on my team, who are current certified, who have done the regular regulation and certified to install. It should be same for everyone. That's why some people want to do solar, and some installer will say, okay, what's your budget? No, you can't be working with a budget on solar. You need this capacity. This is what it will cost. Minimum standard. Your cabling must be high grade. Your panel array must be standard, so that it doesn't go off the roof when it's stormy. Your charging must be high grade. But people bypass and say, okay, don't worry, I'll work with your budget, and then they sell some standard products. Then there's educating the consumer, which, like I said, I'm excited about the event today. We need to have more of this, where we're telling people about what to look out for example. I can't wait to also listen in the background to engineer telling us on how customers can actually what to look out for when you are buying, what to ask. For example, ask for warranties. You can also ask for what we call depth of discharge. Batteries have what we call depth of discharge. It has what we call life cycle. Don't let me go into engineering space because we have an expert that will tell us that. Customers should be able to ask this question: what's the warranty? What's the lifespan of this? What's the life cycle? What is the depth of discharge? And then they know that you know what you're doing, and then they won't sell fake items to you. Then market regulation and monitoring also very important. We need to encourage high quality suppliers. So most high quality suppliers, my company says there's a barest minimum we will never go. So in solar, there are tiers. Tier 1, for example, solar panel, tier 1, tier 2, tier 3. Even batteries, tier 1, tier 2, tier 3. We insist and we tell our customers we stand on tier 1. So if it's panel, it has to be great, top grade, high efficiency solar panel that I want to use. My price might be a bit more, expensive than others, but it gives me also comfort that I don't have to, because I have warranties, from my original equipment manufacturers that we call OEMs. For example, our solar panels gives a minimum of 10 years warranty, and lifespan is between 25 and 30 years. Our batteries that we deploy, we work with batteries that will have a minimum of 5 years warranty, lithium batteries. Although there are other types of batteries like lead acid, tubular, anyone that is not giving you a minimum of 2 years for any of those batteries, please don't go near them. We need to promote advanced battery technology, storage systems, smart monitoring, where consumers can, from their mobile phone, monitor the system installed in their homes. There are inverters and systems that can do that now. And then for compliance, the regulators need to do regular audits. While I was in REAN, we were promoting a culture where all the installation done by REAN members will have a label. Lawyers will have, when they have this seal on documents, accountants also have that same seal, so that when you audit an account, you put your seal on it. They know that you are the one that audited this organization. It should be the same for solar installation, where a stamp, and Renewable Energy Nigeria is working on that, where all my installation will have a seal that I have gotten from the association, that I'm the one that installed this. So if there's anything, I do a solar street light, it's on the high street and it's not working, you can just walk close to the pole and check who installed this solar, and you see my seal and say, one of your solar street lights is not working. That will also encourage high quality delivery. Of course, there are a lot of benefits. I wanted to pitch this picture of my first barber shop, solar powered barber shop. The guys have been running for over 7-8 years now using solar system and no longer using generator. And of course, if we didn't deploy good quality systems, his other member of the association wouldn't have gone solar. And we've deployed a lot of solar barber shops in Nigeria. We insist on standard quality products. So let me just briefly introduce my company. We call Solar Direct. We partner with high-grade suppliers to deploy solar systems. These are some of our partners that work with both local and international. We have very credible board in place. I'm a former banker who came into this space to also set a standard and also introduce what we call financing model. So where you can adopt solar today and pay by installments at an amount that will be cheaper than your grid and your generator, guaranteed. And then after a while, you own the system. And you can also do energy as a service. You get installed. You don't worry about the battery and inverter. You just pay for the use of electricity. I will be happy to take questions. And like I said, I look forward to listening to the experts on what consumers should look out for. Thank you so much. Over to you, moderator.
Thank you so much, Mr. Segun Adaju, for that insightful presentation. You highlighted so many critical issues, and one of which is the importance of standards in the solar industry. Just as no patient would trust an uncertified doctor, consumers should not settle for substandard solar installations. The risk involved, from poor efficiency to even fire hazards. We've seen news reports of solar panels going up in flames, and these things could be avoided if we prioritize quality and certification. And there's also the pressing need to close the policy gaps and enforce stronger regulations. And that I will leave to Prof as she comes up and addresses us. Prof, over to you. Please have your questions ready for Mr. Adaju. Thank you.
Thank you so much. My name is Professor Chinedu Okwaraoka, Executive Director for Consumer Advocacy and Empowerment Foundation. And it's really my pleasure to host you, Dr. Adaju. You've done an extremely great job in breaking down what we have and what we should have. CADEF's mission is really to empower and educate the average Nigerian with enough information to make informed decisions. And that was the reason why we started, when the opportunity presented itself on Renewable Energy, which is a DR solution. On our website, der.cadefng.org, you will have a lot of this information to educate the average Nigerian to go read up on solar panels, read up on batteries, the different type of batteries, what they should be, ask intelligent questions, even be able to, using the solar calculator, to calculate what their energy need is before approaching an installer or a vendor. And one thing we found out when we did our survey, what we found out was what you just mentioned, the different policies that is in place, but the lack of a comprehensive policy, and also the gaps in implementation. We recognize that and realize that, and it's a focus we hope to address in the future on how to bring all of these policies together and have one comprehensive policy that also would include some of your suggestions, tax breaks and incentives, not only for the vendors, the importers, but also for the installers and for the adopters, having tax breaks, having total removal of tariffs, importation tariffs and VATs. We're trying to encourage people. If you're telling a business person to have a solar powered, then give them a tax break. There are ways you can give them a couple of years tax break so that they can recover from providing their own energy. I love the fact that you mentioned about having an act, and it's something we're going to look into and see how we can help to address that. Following the frequent collapse of energy of the national grid, nobody has to tell anybody that it's time that our policies and what is on ground comes together to meet together. The issue of net metering, it's on the books, but I don't see it happening anytime soon because of some of the things you mentioned too. And so today, I know we have some, Rebecca, we may have some questions. And if you have any questions for Mr. Adaju that he wants to respond to, please list it out, and because we want to go, I'm looking at the time so that we can move on to the next speaker. Rebecca, any questions before we move to the next speaker?
Yes, we do. I'll read it out now. So, Mr. Adaju, Ayuba says, thank you, Mr. Segun, for this wonderful presentation. I would like to ask, since product labels and ratings are sometimes misleading, what practical steps can consumers take to verify the authenticity of solar products before purchasing? Should I take it?
Yes, I mean, it's clear. So it's a bit, I do understand the situation you have painted, and it's likely, it's possible. How do you authenticate the label? So I advise people that, number one, deal with organizations that have, for example, some certification, okay, and some association. For example, if I want to hire a lawyer, I'll ask, are you a member of the Nigerian Bar Association? If you are not, it's clear that I cannot deal with you. So I advise people that deal with companies that are members of the Renewable Energy Association of Nigeria. I'm not saying every other one, all other ones are not okay, but at least they have a disciplinary committee. They have an ethics and privileges committee that you can report to. All right. The other will have been to say, look, carry this system to a testing center, and we don't have too many of them in Nigeria. So it's still a game of trust. Just like you have labels on fridges that they are efficient, they have labels on drugs, but NAFDAC went ahead to say, look, there will be a code you can scratch and send me a message on that, and that if it is genuine, you will get a response from immediately. If it's fake, you will know immediately. Maybe that's what the industry should also be looking at, where you can, a hotline. At the time when I was president of RIAN, I was engaging with Federal Competition and Consumer Protection Council, where every one of us who do installation, we must put that number on our installation, that if you have any issues, you're not happy to certify, you have a right to call FCCP&C and let them take you. So these are the measures that probably will help us to be able to ensure that the labels are actually the true and correct labels. Thank you.
All right, thank you so much, sir. Yes, deal with members who are associated with the Renewable Energy Association of Nigeria, and I think consumer education will also play a role here. Read up, stay informed, find out what is it I should know about this. It would help. There's another question, sir, from Philibus. He says, thank you, Mr. Segun, for this insightful and eye-opening presentation. I truly appreciate the valuable information shared. I'd like to ask, how can consumers easily identify solar products that have been approved for sale in Nigeria? Additionally, if someone unknowingly purchases a non-approved product, what steps can they take to report or address the issue?
Okay, thank you. So I'm still the same issue about how do you identify. Okay, I know that products and panels, for example, batteries, they have the IC label. Some of the you can easily see a good panel will have a label behind it, where you can see the wattage, even the voltages, the opening currents. Engineer will tell us this. I learned this when I got into the trade, really. And where you can check all those variables and those numbers. We're also aware that there are some fake labels. Some people pick fake labels on those systems. So it's still, dealing with the right person, going to an approved doctor and not going to a quack, all right? It's still a first level of assurance. But I make recommendation that if you are in doubt or if you feel cheated, you could pick your phone and call the FCCPC. Why am I saying this? When the former DG was there, and I believe the current DG also pursued that, customers will call in. I know of a friend who bought fake laptops from Computer Village, and he felt very cheated, and he just sent a mail to FCCP. Before we knew it, FCCPC went to a Computer Village for redress, and they got the money back. They were almost prosecuting the person, so he had to settle out of court. So, find who to report to, and I would say Consumer Protection Council is, for me, the next line of action. You can also reach out to the Renewable Energy Association of Nigeria. I'm happy to. I'm one of the founders, pioneers. If you have my contact, if you have any issue, we could engage the association for some redress. So those would be my recommendation. And of course, we have the Consumer Advocacy and Empowerment Foundation now. You can just report, because if you report and we make a case of it, it will create awareness and education to people so that they don't make the same mistake again. And the guy is kicked out of the system, and it doesn't continue to pollute the system. Thank you.
Thank you, sir. So we have 2 more questions. For those wondering what FCCPC is, Federal Competition and Consumer Protection Commission, you can, visit their website and drop your complaints there. So, sir, the next question from Oluwaseun: how do we have access to the certifications available?
Okay. So, there are lots of institutions now in Nigeria that conducts training, prepares you for certification, and then you go write the exam. For example, currently runs a certification program. I'm on the board of one of the institutes that has been certified by Current and the ECOWAS to train installers and certify them. It's called Stephen Energy Institute. It's on the aspect of Lagos Ibadan Expressway. There are many other institutions. So I'm also happy to share this information where you can go get trained. They prepare you for current certification, and you write the exam, and you are certified, and then you can practice across the whole of West Africa. So we also need to identify those institutions. You could just go online, Google, say, so there's also NAPTIN. NAPTIN also has a training school where you can also train and get certified. There's one of my colleague who has a school in Ibadan. It's called Ashidam Solar. She also has a school where she trains people, prepare them for current certification, and they write the exam, and then they're certified. Over to you.
Yes, that's wonderful. Thank you, sir. The last question from Uche. It says, thank you for the insightful session, Mr. Segun. One major challenge for solar adoption is affordability. What financing options are available for consumers and businesses looking to install solar?
Okay, very straight. One of the reasons for my coming into solar is to create affordability. Okay, so I didn't come into the space to come and do engineering. I saw a gap as a banker where people want solar but they cannot afford it. So I said my experience in banking, where I've done financing even of Okadas. I mean, if I can finance Okada, why can't I finance solar? So it's one of the reasons why I left banking to come into this space. So I run a company that is completely focused on solar financing and leaving engineering for the engineers to do it. So we partner with a lot of, so for example, if you need solar and you want financing, I should be your plug. And then we partner with banks to do this, both microfinance banks, commercial institutions, for example, Sterling Bank, FCMB. We're talking to two other banks, and it's any size. So, and we will prove it to you that once you are generating power through other means, either generator or you are using the grid, I will provide solar power that will be relatively cheaper than what you are spending on your generator. And that was the first value proposition we gave to Babas. To say, look, yes, we are buying 5 liters per day at, say, 800 naira, do the math, 4K per day. I will give you a solar system that will cost you less than 4K per day, 2,500 per day. And then it will power your business. And you don't need that generator. And it will guarantee you power, consistently. So this, there are other players also in the market. So you could walk into any FCMB branch and say, I need solar, but I don't have money to buy it now. They will tell you what to do. And we can also, of course, I'll drop my details. If you need solar, please reach out to me. Thank you, moderator.
That's very wonderful, Mr. Segun. Thank you so much. We still have so many questions coming in, but I doubt that you have the time to answer. So we'll probably just forward them to you, and you just craft a response to them, and we will reach these people.
Yes.
Thank you. Really,
thank you so much. Thank you.
And I would like to quickly mention, thank you very much, Dr. Segun. But also on the CADEF website, we are trying to generate a list of viable vendors. So don't fail to register your If you're a vendor or a financial institution, don't fail to register on the CADEF website, because then it'll give us the opportunity, as long as we know you're certified, to make these information available to consumers who are interested, to create a pipeline of consumers looking to register on der.cadefng.org as a vendor, as an installer, or in the financing area. And we will get these names out to those who are interested in adopting solar. Thank you.
Thank you.
Thank you for that information, Prof. That was very helpful. So right now, we are moving on to our next speaker, Engineer Chinedu, as he talks to us.
Yes, hello, good afternoon, everyone.
Engineer Chinedu, thank you for joining us. You're welcome. You have the floor now.
Good afternoon, everyone. I'll be speaking on. Before I start, can you enable my video? All right. Yeah, good afternoon, everyone. My name is Engineer Chinedu. I'm speaking on the practical aspects of solar panel usage. I'll be sharing some few items on my screen that we have. So my focus is going to be on what every consumer will want to know before actually going with solar. All right. Moderator, please tell me if my screen is not clear enough.
Your screen is clear, sir.
All right. So, the users of solar in Nigeria are having a lot of problems, as the first speaker mentioned, and a lot of these problems have to do with what we have available to us as Nigerian solar, potential solar users in Nigeria. In my presentation, I'm going to start with the aspect that talks about what is efficiency, what is actually battery storage. Every solar panel that you have out there in the market is meant to do one thing: to take energy from the sun, and take the radiation from the sun and convert it to energy for you to use in your house. And this energy comes in a particular form. Now, the ability of that solar panel to take this energy and convert it efficiently with as little loss as possible is what you call the efficiency of the panel. And no solar panel in the market is 100% efficient. And this energy that your solar panel is generating for you will likely end up in one of the appliances being consumed or stored in a way that you can reuse it later on. That is where what they call battery storage comes in. In the production of solar panels for consumers, there are organizations that have taken it upon themselves to try to make sure that whatever the consumer gets is what they actually pay. And these are what we call the standard organization. They go out there, take up some of these panels that have been produced and test them thoroughly. Then the result of their test is published and also made known to the manufacturer of the product. So over time, some of these organizations have become very, very efficient in their duty and have come to become trusted by both the consumers as well as the users. What now makes the manufacturers of these products so this now makes the manufacturers of the product that we use so seek out these standard organizations, give them their products to test for them, and actually pay for the test. At the end of the day, they get a badge for their product, a badge that will look like what you have on the bottom of the screen here. Some of the badges like the UL, like the one of the standard organizations that test for, they're called the underwriters. Sorry, they're called the underwriters laboratories. And then the ISO, that's International Organization of International Organization for Standards of Standardization, and then the IEC, as mentioned by one of our earlier speakers. The IEC is one of the organizations Nigeria is looking up to adopt their standards in the products that we're going to be using in Nigeria. So, why does this standards that we are talking about matter? Every user will want to have a good done for their money. You want a situation where if you pay 1,000 naira for a product, you get 1,000 naira value for your product. So these standards guarantee the products that we are buying in the market. It gives us that assurance that this product is actually what the manufacturer says it is. It helps the consumer in making their purchases. It makes you feel safe that whatever you are buying is not going to cause you problem in future. Like when the moderator mentioned the solar fire, the solar panel is going up in flames in roof of some people. Many consumers will not want to have such a thing happen to their building. So you want a situation where the materials you're getting for your product, for your solar system, is going to be safe and reliable. That is what this standard verification is. In Nigeria, there are a few organizations that have been set up, or policies that have been made to help the Nigerian users also keep it. Not going to go into details of this, but the speaker has really covered it in enough detail. Now let me go to the very first thing that every solar user will always want to know. What does all these things that they write on the label of the solar panel really mean? How do I know that what this solar panel is displaying on this body is what it's actually going to produce. The first thing is the wattage, what they call the power rating of the solar panel. This gives us an idea of how much power and how much energy we can eventually get from this solar panel. This power rating is what some of the users use in confusing consumers a lot. So a lot of the time the consumer will buy 20 solar panels, 40 solar panels and put on their roof. And then they'll come back to you complaining that we have all these solar panels and we're not getting what we really wanted from the system. It's not working. What could be the problem? Now, these consumers are looking at the number of panels. They do not have any knowledge of what power can each of those panels they have on their roof produce. Because these are what cumulatively produce what we call energy generation in your house. So you need to have a very good, at least reasonable knowledge of what this rating is all about. The first one is the power rating in watts. If you look at the model of solar panel I'm giving here as an example, this is a 415 watts solar panel. Now this wattage comes with two other parameters that are very important, which is the voltage. If you look at the voltage, you will see two voltage ratings here. One is the one they call the Pmax, as the maximum power voltage. This is the voltage this panel should be producing on its terminals when it is producing this power, 415 watts. Next one is the open circuit voltage, called DOC. In this particular example, we have the maximum power voltage as 38. I hope the participants can see what I'm trying to point at. And the open circuit voltage is 45 in this case. So every installer should know that the choice of solar panel must be made with this particular parameter, the open circuit voltage, taken into cognizance. The user will not know this, but the consumer, the user, wants to have this power, this 415 watts delivered from the solar panel for him or her. Now that brings me to the next item, which is the current, the short circuit current. Now, if you look at the panel, you will see a value written ISC in bracket, short circuit current. This particular instance is 11.6. Now, it will not be exactly the same thing for every solar panel that is rated 450 watts. But one thing is certain. If you are going to the market to buy solar panel, you want to buy a solar panel that has this value produced from the terminal of that solar panel. For instance, one of the earlier questions I was asked, what practical steps to choose your solar panels and solar material. One of them is what I'm showing you here. You go to the market to buy solar panel, you don't have the necessary equipment to take measurements, take your installer along. And your installer must have the necessary equipment, something like a multimeter that can measure current. Preferably what they call a current meter. Now, that installer is to bring out the solar panel under the sun, direct sunlight preferably, and short the wire, take the positive and negative of that solar panel, short them together, and then measure the current that is flowing inside that solar panel. That current must not be far from this value, short circuit current. If it is far from it, take for instance, you have this 450 watt panel and you measure the short circuit current, instead of getting 11 or something close to 11, you are getting around 5 or 6 amps when the sun is actually shining. Please do not buy that solar panel. It is not what is rated. So that panel is likely a panel that has been relabeled, a panel where the marketer or the importer has brought into Nigeria, passed all the necessary checks that they see, then went to the printer and printed a label of his own choice. Will be a panel that is 200 watts, will now go and print a panel of 415, print a label of 415 watts and put on the panel. So when you are buying, you will think you are buying 415 watts when you are actually buying something that is about 200 watts. Now, I said earlier that solar panels will not produce 100% their rated power. This is true only when the sun is not directly over the solar panel, what we call a perpendicular to the surface of the solar panel. That is, if the sun is at 12 o'clock, the sun is directly above your head and this panel is lying flat on the ground. Under normal circumstances, that panel is supposed to produce the rated power. But when the sun is at an angle, we will speak a little more about it later on, you will not get the full rating of that panel coming out from it as power. Then the other item that you always hear is things like ampere hour or kilowatt hour for batteries. I struggle to try and make this not technical so that everybody will have a grasp of what we're talking about. A battery today is commonly referred to by its ampere. So a user will always tell you, I have a 200 amp battery, I have a 300 amp battery, I have 100 amp battery. What this really means is that battery can produce the current you are mentioning continuously for a certain period of time. So if you have 100 ampere hour battery, which every user, every man out there will call 100 amps battery, that battery can produce 100 amps continuously for 1 hour before becoming empty. That is, before all the energy it has stored is drained. Now this is very, very applicable to what we call the lead-acid battery. We have a short while later we're going to see some of them. But when it comes to lithium batteries, you start hearing things like 1 kilowatt hour, 5 kilowatt hour, 10 kilowatt hour, 15 kilowatt hour. Now this is just the same thing, the same ampere hour that we talked about, but right now multiplied by the terminal voltage of the battery. So for instance, you have a 12 volt battery that is rated for 100 amps. If it is lithium, it is very likely that the manufacturer or the seller will tell you that this is a 1200 watt hour battery or 1.2 kilowatt hour battery, which is simply the voltage times the ampere hour rating of the battery. Now let's talk about the lifespan of battery. These two batteries I mentioned, the lithium battery and the lead-acid battery, they generally have very diverse lifespan, which is the length of time that battery is going to last for you. Now, this length of time for a typical battery is calculated based on the number of times you charge it and discharge it. If you should charge your battery continuously for 1,000 times, as in charge it and discharge it for 1,000 times, and that battery dies after the 1,000th charge, or the battery starts producing something far less than what it used to produce when it was new, then you will say that that battery has reached the end of its lifespan. In other words, the number of charge-discharge cycles of that battery has been exhausted. So a typical lead-acid battery will offer you things maybe of 1,000 to 2,000 and go up to 3,000 cycles, while your lithium battery, especially lithium iron phosphate battery, can boast of producing in excess of 4,000 to 6,000 cycles. Now, this number doesn't mean so much, only when you take into context how you charge and discharge your battery. Let's say you have a solar system that you have designed and installed, and the system is properly sized in such a way that your battery gets fully charged in the daytime and then maybe discharged or not fully discharged at night. So let me take an instance of being fully charged in the day and then fully discharged before the morning of the next day. Then you have one cycle in your battery per day. So what that means is that if my cycle is 1,000, my battery lifespan is 1,000 cycles, then I can get 1,000 days from that battery. If the battery is 6,000 cycles, I can get 6,000 days from that battery. Now, if you convert this number of days to the day, you can see that a typical lead-acid battery can give you about 2 to 3 years, especially those ones that are available in Nigerian market. While your lithium battery, lithium iron phosphate battery, can give you upward of like 10 years. Now remember what I said earlier, this number of years or the cycles does not mean that the battery is 100% dead at the end of that cycle. For a lithium battery, after that number of cycles, it could have about 80% capacity remaining, which means if it is a 100 ampere hour battery, you might be getting about 80 ampere hours from it at that point. And if it is for lead-acid and you have say 100 ampere hour, you might be getting maybe about 50 or 60 ampere hours left. When we go to the next slide, I'm going to make some of the terms that are of importance to me as a user. I'm a user of solar system and I'm talking about my storage. I want to know what this DOD is, what is called depth of discharge. I want to know how much power can I really take from this my battery? If my battery is rated 1,200 watt hour, like I mentioned about this one, can I get 1,200 watt hour from it? Or am I limited to getting only 50% or 60% from it? Now that is what is called depth of discharge. For leadership, it is recommended that you limit your power draw from the battery to about 50% of its capacity. That is 50% DOD or 50% depth of discharge. And for those ones that they call cycle battery, leadership deep cycle battery, it may go up to 60% without killing the battery outright. But you want to still limit it within that 50-60% range so that the battery can give you the full length of service in this lifespan. But for a typical lithium-ion phosphate battery, you can get 100% of its capacity. That is, if it is rated 100 ampere hours, you can actually discharge. If I take a load, I can get 100% of what that battery stores without damaging the battery. But then, the manufacturers also tell us to limit our storage, our usage to about 90% of the capacity. Let me go down to some other terms that are important. I've gotten a one line on my system. For solar panels, there are different types. You have the monocrystalline, the polycrystalline, and the thin film. The most common one in our market today is this monocrystalline, and most people will tell you buy mono cells, that they are better than the polycrystalline. But at the end of the day, your budget for the system will actually dictate which one you should go for, because all of them work fine. But you have more on monocrystalline. Solar panels can be mounted on the ground or on the roof, and if you look at the right hand side of my screen, you can see this thick roof with solar panels mounted on it. It is a very common thing in Nigeria. It's not a very good way to mount solar panels, because what you get from here is not going to be anything near what the panel can produce. If you look at this animation, if you have a solar panel that's mounted on the floor with the face facing the sun generally, then from the sunrise to sunset, you are likely going to get energy from the sun, from the system, from morning till almost night. But if on a roof like this thick roof, then you only get half of the day, or less than half of the day, from your solar energy. So you want a system where you have all the energy that the solar panels can produce from morning to night. Common battery types, I've mentioned several of them, the lead-acid batteries and lithium batteries. Lithium batteries are more compact than the lead-acid batteries. Lead-acid batteries are actually bulk. For inverters, you want your system to be using what we call the sine wave inverter. That is one that has a waveform. The output waveform is very close to what you get from your public utility. There are other waveforms that are available, what they call the modified sine wave and the square wave inverter. But you do not want this one if you can afford this. your sign with it. Troubleshooting and the maintenance kit for your system. I just did a rough illustration here. If your solar panel is producing total of 2000 watts at an instant, you do not want a load system that will consume all the power that the solar panel is producing. You want a system that will take some of this energy and store it in your
Engineer Chinedu, I think we missed out on some of what you were saying. Can you hear me, sir? Okay. No, not really. Your audio has gone quite low.
Hello, moderator, are you hearing me?
Yes, we can hear you now. I can hear you.
All right. Please, can you remind me where my audio got lost?
You were talking about, I think the first point, the panel positioning and cleanliness.
Okay. All right. So, you want a situation where your solar panel produces what it is rated for. And I was talking about this illustration at the bottom of the screen. If your solar panel is 2000 watts, your load should not be 2000 watts during the time the battery is supposed to be charged. You want a situation where a good amount of this energy that is coming from the solar panel is going into the battery for storage. And you do not want a situation where the whole energy that is being generated from the sun is going first to the load with nothing being stored in your battery. So you want your system to be very clean, like the first point I mentioned, as having sufficient solar power output from your system. You want the system to be clean. You want the solar panel to be very clean, so that it will generate what it is rated for. You want the battery to be properly charged. The first speaker said the battery gets into float mode around midday or before midday. What he was saying is that the battery is fully charged before 12 noon. And you want such a system that will be able to charge up your battery on time. I bet you may be using a lithium battery installation, which means you can actually allow this battery to charge faster than you will charge a lead-acid battery. So your lead-acid battery takes a longer time to charge. So you have to provide it enough energy from the time it starts charging to the time it's full. But if you have lithium batteries, you can utilize what is called fast charging. So you can charge up your battery in 2 hours or in 3 hours, as the case may be, without damaging the battery. So if your battery has poor charging, you should ensure that your charge controller settings are okay. The panel is properly sized. This is only important if it is a new installation. I think your installation was doing very well at the beginning when it was installed, and then suddenly things got out of hand. It started doing bad. Then you should check things around the power connection, the wire being used for the connection, whether some degradation has occurred, especially in systems where installers do not use proper termination methods, where wires are filled and joined, twisted together in half, and then maybe solicited. easy for that type of installation to get water ingress, and water will enter the zone, heats up the copper that is exposed, and then the whole thing becomes a high resistance zone. Current will no longer flow, and then your system starts to fail. But if it's a brand new system that you installed and you're having this problem of poor battery charge, then there is every likelihood that your system was not properly sized by your installer. The installer should make sure there is enough solar panel to charge the battery during the day and support the loads that are going to be turned on during the daytime. So in this my illustration, there is a bottom of a screen. 2000 watts is not enough. 2000 watt solar is not enough for this system. If 1900 watts of load is going to be on all day long, then you want something way more than 2000 watts. You want something like in the range of about 4000 watts coming from the solar panel, so that you will be able to send this 1900 watts to the load and then send the remaining 2000 to the battery for charging. This is so because your system, your inverter system, will always take the load as the first priority. You support the load first before trying to charge the battery. In fact, if the energy coming from the sun is not enough, your battery will start charging during the day. The battery will be supporting the energy coming from the sun to carry your load. That is not a solar system. The type of solar system you want. You want a solar system that works in storage mode only all through the day, and then at night the charging of the battery can connect. I usually prefer a system that can start discharging the battery from around 4 or 5 p.m. and then the battery will now be charged all night to the morning when charging the connect. Now, there is something they call days of autonomy. In Nigeria here, installers do not practice that. Why? Because a typical Nigerian solar client wants something that will just carry its load. Doesn't want to have any excess power, because give it to us, things are hard, the economy is tight, and then the situation is not that easy for the customer. But he still wants a good life, something that will support him and save him some money. That is where the mention of budget comes in. I had the first speaker talk about the installers telling the client that they will work within your budget. Well, it is not true. They don't work within your budget. What they do is try to cut costs and maximize profit, while you get something that will discourage you from ever going back to solar. So most of my clients that has done installation before I came into the picture had a system where their solar panel is managing to charge their battery. Because at the onset of the installation, they must have agreed with the installer to work within the budget, and the installer will go to the market. Like I said earlier, you want numbers, you want to show the customer that he has enough panels. So you go and buy cheap small panels, fill up everywhere with solar panels, and then put small systems that will not really do the job for the client. So when you come and reassess the system, you start realizing that what the person has cannot really support it. So the only option for the customer in that case is to either upgrade the system by increasing the number of panels he has, or downgrade the load, reduce the amount of load he's giving the solar panel. So I'm going to come a little back to this later on at the end of the slide. So if your system is having fairly shut down, what could be the cause? just like we discussed in this first 2 points, early shutdown is that your battery is not chargeable. So consult your specialist on sizes, proper mounting of solar panels, and so on. So regular cleaning of solar panels at night. Regular cleaning means maybe once in 3 months or once in 4 months, depending on how dusty your area is. If it is very dusty in your area, you can actually look at the panels and see how dusty it is. So you can always order for cleaning service to be done on it, or if it is on the ground, and let water and some cleaning materials and white down stuff on the solar panel. Now inspect your wiring connections periodically. This is not for the user, but I would advise the user to monitor their system, monitor the energy they are generating. When things start becoming unusual, consult your specialist. Let your specialist know so that they can go into your system and check your wire connections, make sure everything is still in order. Now, if you monitor your battery charge and the charge cycle, if the solar panels are good and your batteries are not good, the solar system will not work because they are a system. I did not mention this earlier. For those who don't understand, the solar panel generates energy from the sun, but this energy is not usable directly to you as a user. That is why you need your inverter. Now your inverter will convert the energy that is coming from the solar panel to energy that is usable in the house. Now that battery is there to provide you power when the solar panel is no longer able to produce power, because the solar panel is constrained to producing power only when the sun is shining. When the sun goes down, energy from the solar panel is gone. That is why storage is also very, very important. So monitor your battery. Make sure your batteries are doing well. Make sure they are charging fine and also discharging properly. You should not over discharge the battery. You should not over discharge the battery. You should make sure your battery only charge and discharge within a specific range of depth of the charge that is recommended. But if you must, assuming it's an emergency and your battery has to go down 100%, yeah, by all means, go down to 100% if it is a lithium ion phosphate battery. But if it is a lead acid battery, do not do it. It is not advisable at all. Once your battery is down, find an alternative. So I made a side note on that here that you should avoid allow the battery to charge up fully by reducing the avoidable loads. So some customers will turn on every single thing you have in the house when the sun is shining. And when you ask, they will tell you, the energy is coming from the sun. So why not use it? Yes. Is your battery fully charged? Is your battery charging fine? If your battery is not charging fine, then there is no reason to turn on all those loads that you see. Only turn on what is usable and what will allow you to take some charge. Now, some of the best practices that recommended is use high quality properly sized cable and connectors. The first speaker mentioned this. You should store batteries in well ventilated area, especially if you are using tubular batteries. They produce some gas that is not good for you. So you want those gas to be exhausted from where it is being produced, especially during charge and some heavy discharges. Get an expert to publicize your system before installation. That is, if you have not installed this, get several opinions about what you actually need. There's every necessity that you should do a load survey. Find out what you have in your house that you want to power from the sun before you go in. Otherwise, you will be one of those unhappy solar users when you have finished doing your installation. Now, do not introduce new loads at random. I'm not saying you should not buy new devices. But if you are buying new devices that are going to be powered from your solar, also consider the type of solar you already have. When you do your installation, the initial charge on your budget, the amount of money you spend putting this system will range most of the time. So most of the time we continue using some of the old inefficient devices to have in house after doing our solar installation. So it's advisable that after doing your solar installation, gradually change some of these inefficient devices. You usually hear about battery freezer, battery fridge, battery AC, battery washing machine. All those devices are high efficient devices that are now in market, but they are more expensive than the other ones. But what they do for you is that they allow you to maximize the efficiency of your solar system. And if you are already using these devices in your house, then your solar system will not necessarily cut a very big hole in your pocket, because they are not being sized for being efficient devices. They are being sized for devices that are already energy. There is every reason why you should monitor your system through apps and contact controllers. In conclusion, it is initially expensive to go solar. I mentioned this in passing, but you want your return on investment when you have done this installation. So don't go to sparks. I'm not saying that they cannot install your solar, but consult people that know how to size solar, so that when you come out of it, you will relax and start waiting for your system to pay for itself, instead of continuing to make expensive on it. Like in every aspect of life, there's no one size fits all. What the client will always say is that my neighbor did installation, have 4 panels, 4 panels. But your neighbor may not be using exactly the same type of load that you are using in your home. So 4 panels may not be adequate for you. So proper sizing is very, very important. Again, do not make poor choices of solar equipment. This one is very cheap, so let me go and buy it. Most of the time you end up thinking, you go and buy this system and come out from installation unhappy that you have actually done installation. One of the things that really cause problems for us is second-hand equipment, second-hand solar panels, even used batteries. So most customers will say, what about used solar panels? Yes, used solar panels are good. And in fact, our Alaba brothers will go and get a published panel, put them in carton, put a fine label on them, and sell it to you as a brand new solar panel. That is where your source of equipment is very, very important. You should buy from only trusted sources. If you do not know these sources, buy from experts that you can trust to source for these materials. In conclusion, there are some few notes I took when the first speaker was talking, and I want to say one or two things about those points. Like when you mentioned floats, what I mean by floats is that the battery is 100% fully charged, and it is now just idling. That is, it's just waiting for the time when energy will be demanded from it, when power will be demanded from it. That's when it is back to charge. The other related term to that flow is bulk absorb. During the charging of battery, there are typically three zones. The first stage, which is the bulk stage, where power is pushed into the battery as much as possible. That is, if the system can take 100 amps as input current, as charge current, you will be pushing 100 amps into the system at that moment. In this moment, that bulk moment, voltage is not really an issue. That is, battery voltage is not a problem. But once the battery has charged until it gets to its nominal voltage, like if you have a 12 volt battery, if the battery gets to around 14.4 volts or thereabout, then the next stage of the charging will commence, and that next stage is called the absorption stage. This is where the system, instead of continuing to push charge into your battery, it will now start monitoring your battery voltage and reducing the amount of charge it's pushing into this battery in such a way that this voltage does not go above that 14.4 volts. So a typical lead-acid battery will go from around 8 to 9 volts all the way up to 14.4 when it's in normal charge. So during that absorption stage, it will be 14.4, and most customers will say, "My battery is full." Why? It's not working. Yes, the battery is not full at that moment. Battery is being charged, and it still requires a lot of charge. So a lithium battery, for instance, might stay in this absorption state for 2 hours with all the currents that was being pulled still going in without really reducing. So most customers will not say you are my battery is full and this will just went off very fast. No. If you cut charging at that moment, if for instance you are monitoring your loads and you wanted to turn on some heavy loads when the battery is full, and you just see this 14.4 volts and turn on the heavy loads, thinking at the battery, you may have cut down the charging of the battery because the battery is not yet. Your battery has to be in float. That is, it has stayed in this 14.4 volts for a certain period of time and reduced voltage to what is called float voltage. So you can reduce from 14.4 volts to about 13.8 volts or 13.6 volts. It is a 12 volt system, and stay on that 13.6 or 13.8 volts permanently. You are not going to see any voltage that is lower during the charging cycle in that particular stage. So that is called float. So this battery must pass through these two stages: the bulk, the absorption, and the float before it is fully charged. So one way for you as a user to know is monitor the current that is going into the battery. If the current that was going in is 100, and then suddenly you see 14.4 volts, and this current starts dropping from 100 down to 50, 20, 10, 5, and it's still staying at 14.4 volts, then you can say our battery is full. Because when the battery is full, little or no current goes into the battery. Then the other item I noted down is the aspect of practical steps to take. I mentioned it in the beginning. Buy from the right source. Do not go to the market on your own to buy solar materials unless you trust your source. If you are 100% sure of the person that you are buying from, then buy this thing by all means. But if you are not sure, go with a trusted installer or expert. They will make the proper choice for you, so that you finish your installation, there will be no need for grumbling and unhappiness at the end. Thank you.
Wow, thank you so much, Engineer. Thank you for that insightful discussion, for breaking down essential terms such as depth of discharge, wattage, battery lifespan, troubleshooting. You know, it would sound simple on the surface, like the sun just has to shine, my panel will work, my lights will come on. But the real magic is in the details. Like, you have to understand these key factors, so consumers do not end up with a system that is more decorative than functional. And we've spent a lot of time. We're taking a lot. We're taking. I was taking notes. I don't know if you were, because Engineer Chinedu really went all the way, you know, from explaining and helping us break down these terms. And so we have one question from Oluwaseun. We're taking just one question because we've gone far. Let me get Seun's question. Seun says, thank you, Mr. Chinedu, for the insightful presentation. You elaborated on the life cycle of the battery. Could you also share your thoughts on the lifespan of solar panels? At what point can they be considered for replacement or disposal? Engineer Chinedu, did you hear my question? Okay, you heard the question.
Yes, I got the question. Yes, solar panels, I didn't go into their lifespan because for the time the technical has spoken about it well enough. Your solar panels have a lifespan, right? So if they're usually a brand new panel and it has lasted you for 25 years, then you should start making arrangements for replacement. Not that you should replace it immediately, because at that 25 years you would have seen degradation of the battery. But 25 years will give you the capacity, the lifespan of all the materials that used in making that solar panel. Things like glass, the laminate material, even the circuitry, the bus bars that carry current from those solar panels. So the lifespan means that these things by 25 years they would have reduced in their efficiency to a certain level. So it is not left for you as users at that moment and start looking at how well have they been serving before, how well are they now start making your move or investment. So when you throw them away, it's actually left for you. You are the one that will be monthly or if you are not, the solar is you providing you service. The solar will know at what point then will the solar panel will be. But if it is second-hand solar panel, you do not know how long it has lasted, how long it has been observed. So once you start seeing deterioration, physical deterioration, maybe cracks on the cell under the glass, then I suggest you start looking for replacement.
Okay, Oluwaseun, I do hope your question has been answered. Thank you, Engineer Chinedu, for attempting that. So a lot of emphasis have been placed on quality installation, quality materials, regular cleaning. Even our last speaker talked about quality, certification, standards, policy gaps. So these are what we focused on today, and I do really hope that this conversation will go beyond this session. So I want to say a big thank you, first of all, to our speakers for their incredible contributions. We've had an enriching discussion today, and we encourage everybody to keep the conversation going. Make the most of the resources that have been shared during this session. Thank you for sharing your expertise. Thank you to our attendees for your engagement and your thoughtful questions. We encourage you to stay connected with CADEF. We have partners. We have COATEC. We have Any Workman. If you're thinking, where do I go to? Who do I talk to? How do I connect with vetted installers, vetted distributors, vetted maintenance companies? We have them on our DER website, so you can log on, visit der.cadefng.org, to see what it has to offer. And just before we go, Prof would like to say a quick word to us. Prof?
Thank you so much. It was really insightful meeting. Thank you, Mr. Segun. Thank you, Mr. Chinedu. It was an amazing opportunity to hear. I thought I knew much, but by the time both of you came on board, I want to take some more lessons from both of you. Please remember to visit the CADEF website, der.cadefng.org, to get more information. We have partners we're working with, and we would like you to, if you have questions, reach out to us by email, info@cadefng.org, or you can call us. We have partners like COATEC and Any Workman, and very soon we'll be speaking to other vendors as they sign up and get verified and certified that we can recommend to you. Thank you so much. We do have another webinar coming up in March and April, so look out for that information. If you have questions you want answered in the next webinar, please put it on the chat box, and we will try to get more engaging presenters that can answer your question. Thank you. We've kept you long enough. Have an amazing rest of the week, and don't fail to visit us. Goodbye, and God bless you.
Thank you. You can follow us on via the handles displayed on the screen. We are active on all our social media platforms. Thank you so much for staying through till this time. We hope to see you in our future sessions. This recording will be available on our YouTube channel at CADEF NG. Once it is up, you get an update via social media. So do well to follow us so you get updates. Have a blessed day. Bye for now.